Hello everyone, here is the chapter 3. Okay, so in this chapter also we're going to be learning a lot of formulas, a lot of calculations, a lot of way of thinking. Okay, the material that you're going to learn in this chapter also take the same form like we did the unit conversion in our chapter 2. Okay, so with that in mind, so we'll go ahead and get started. Okay, so in this chapter, we're going to learn about the stoichiometry of formulas and equations. We're going to learn about the mole. Mole is the language that we talk in chemistry. Okay, so we're going to be using the mole concept a lot throughout this chapter and many more chapters to come. Okay, and then determining the formula of an unknown compound. We're going to learn how to determine the formula of an unknown compound. We're also going to learn how to write how to write an equation and how to balance the equation. And also we're going to learn how to calculate the quantities of reactants and products. The mole. So what is the mole that we are so excited about in chemistry? The mole, or sometimes you can write it as MOLE or MOL, is the amount of a substance that contains the same number of entities as there are atoms in exactly 12 gram of carbon 12. So carbon, if you look at your periodic table, atomic number for carbon is 12. Okay, meaning if you take 1 mole of carbon, it has 12 grams. The molar mass of carbon is 12 grams. So you take 12 grams, and how many entities are there in 12 gram of a sample of carbon is the mole. So this term entities refers to as atoms. It could be number of atoms in 12 grams of carbon 12 sample, or it could be number of ions, it could be number of molecules, it could be formula units or electrons, in fact any type of particle. You can also consider the mole as a dozen. When you say dozen, how much that means? Dozen means 12 things. It could be dozen eggs, 12 eggs, dozen students, dozen books. So you can call many different entities, but the dozen amount as 12 remains the same. So likewise, 1 mole could be ions, atoms, molecules, formula units or electrons, but this 1 mole is this amount. 6.022 into 10 to the 23 entities, up to 4 significant figures, and this number is called the Avogadro's number and is abbreviated as capital N or big N. Okay, so 1 mole, so just like a dozen is 12, 1 mole is excuse me, this many number of entities. Okay, so for example, if you take a carbon 12 gram of carbon 12, it has this many number of atoms, it has this many number of ions, it has this many number of molecules, it can have this many number of formula units, or it can have this many number of electrons. Okay, so these are 1 mole of some familiar substances. Okay, now if you look at your periodic table, it's a good idea to have your periodic table handy when you are listening to these videos. You can see that each atom has a mass. That mass is given in grams, and that is given for 1 mole. If you take 1 mole of a substance, that is the mass. For example, carbon, if you take 1 mole, the mass of carbon is 12 grams. What about the mass of 1 mole of hydrogen, which is the molar mass of hydrogen? 1.008. Okay, and what is the molar mass of oxygen? Oxygen, again you refer to your periodic table. 1 mole of oxygen is 16 grams. So here you can see, so this is in the first beaker, what you are seeing is some copper metal, right? So you can refer to your periodic table and see what is the molar mass of copper. Copper, I believe, is 63. I need to have my periodic table handy with me here too. So copper, I believe, is 23. So this is about 63 grams because 1 mole has 63 grams of copper, which is the molar mass of copper. Okay. And then you have a graduated cylinder, and inside the graduated cylinder you have water. So water is H2O, right? H2O is water. Now what is the mass of one water molecule? There are two hydrogens. Each hydrogen is 1.008 and there are two of those. So that's the mass of hydrogen. And oxygen is 16 grams per mole. And when you add it up, it's about 18.016 grams, right? 18 grams. So if you look at the graduated cylinder that has water, that is about 18 milliliters because the density of water is almost 1. So the volume you can be represented as 18 milliliters of water represent 1 mole. Okay, and then the next one, I believe it is table salt sodium chloride. Again, so this is about 1 mole of sodium chloride. How do you find the mass of that sodium chloride? Sodium chloride, and sodium is 23 grams per mole, chlorine is 35.45 grams per mole. Okay, so when you add this up, it's about 58 grams. So you can see 58 grams of table salt are right there. That is 1 mole of a substance, because in the periodic table you have these masses grams per mole. Okay, and then the other beaker what you have is sucrose or sugar molecules. So if you look at the formula for the sugar, that's going to be C6, H12O6 is glucose, and sucrose would be C11H22O11, I believe. So when you add all the masses of the atoms, you will have, for glucose, it's about 180 grams. So what you are seeing here is about 180 grams. That is again 1 mole. So you can see 1 mole is a big amount, right? And then you have crumbled aluminum foil. And aluminum, I believe, molar mass is about 27. So that's about 27 grams of aluminum. Okay. So that's 1 mole of some familiar substances. Molar mass. So the molar mass given in the Italian big M of a substance is the mass per mole of its entities. Mass per mole of its entities. Okay, if you take 1 mole, what is the mass of its entities? Remember, entities could be atoms, molecules, or formula units. So for monoatomic elements, meaning single atom, the molar mass is the same as the atomic mass in grams per mole, which you find from the periodic table. Atomic mass is simply read from the periodic table. The molar mass of neon, 20.18 grams per mole, like that. And then if you have a molecular element or for a compound, the formula is needed to determine the molar mass. The molar mass of oxygen, there are 2 oxygen, 2 times the mass of 1 oxygen, 2 times 1632 grams per mole. You see here, always the molar mass is written as grams per mole, meaning for 1 mole, what is the mass? And molar mass of sulfur dioxide. Molar mass of sulfur, there is 1 plus 2 molar masses of oxygen. So 2 times 1632 plus 32, mass of sulfur is 32, 64 grams per moles. That's how we find out the molar mass of compounds. Now this is the chemical formula of glucose, C6H12O6. Now, not only for glucose, but for any formula that we come across, you can consider that we can find this information in this formula, in this chemical formula. Let's see what are the information we can find. Now, let's see the number of atoms per molecule of a compound. So, if you take one molecule of this compound glucose, how many carbon atoms are there? There are 6 carbon atoms. How many hydrogen atoms? 12. How many oxygen atoms? 6 atoms. So for one molecule, you have 6 atoms of oxygen, like that. You have that information. And then if you want to find out, if you take 1 mole of a compound, the number of moles of atoms. If you take 1 mole of a compound, there are 6 moles of carbon atoms. There are 12 moles of hydrogen atoms. There are 6 moles of oxygen atom. And all that is in 1 mole of this compound. Okay. And then if you want to find out the atoms per mole of a compound, what's the number of carbon atoms per mole of a compound? So there are 6 times Avogadro number of atoms of carbon in 1 mole of a compound. Okay, because there are 6 atoms, so you have to multiply 6 times the Avogadro number, because 1 mole of atom has Avogadro number of atoms. Similarly, hydrogen, there are 12 hydrogens, so the number of atoms per mole of a compound would be 12 times the Avogadro number of atoms for hydrogen. And for oxygen, there are 6 oxygen. So atoms per mole of compound, 6 times the Avogadro number of atoms of oxygen per 1 mole of a compound. Okay. And then if you want to find out the mass per molecule of a compound, there are 6 carbons, so 6 times 12, because each carbon is 12. So 12 times 6, there are 72 grams of carbon. And 12 times the molar mass of hydrogen, 12.10 atomic mass unit of hydrogen per molecule of a compound. And then 6 times 16, oxygen is molar mass 16, 96 atomic mass unit. Now the atomic mass units and then the mass in grams, they are the same. So mass per mole of compound, it's the same amount, 72 grams, 12.10 gram, 96 grams. Okay, so if you have 1 mole of a compound of anything, individual amounts are going to be considered or explained like this. Okay. Interconverting moles, mass and number of chemical entities. Now, this information is needed for us to do some of our calculations. If you want to find out the mass of a compound, if the number of moles are given, let's say you are given number of moles and you need to convert to find out what is the mass of that number of moles. Always you write the number of moles given and then you can use the molar mass, because the molar mass is grams per mole. So 1 mole has this many number of grams, which this you find from your periodic table. Similarly, if the mass is given, you want to find out the number of moles, you first write down what's given, mass, and then you use the molar mass from the periodic table. Now we're going to inverse it. 1 mole is the mass of grams. We'll do some examples, you'll get it, okay? And then if you want to find out the number of entities, if the number of moles given, we know 1 mole of a substance has this many number of entities. So you can use this equation. If the number of entities are given, you want to find out the number of moles, you can use this equation where 1 mole has this many number of entities. Just like we did our conversions with the unit conversions in the previous chapter, we can use it however the way we want it based on the amount that we are trying to find out. Okay. Okay. Mass to mole number relationship for elements, it tells you, you can, if you know the mass, you can find out the number of moles using the molar mass. Similarly, if you know the moles, you can find out the mass using the molar mass. And to go from moles to atoms or molecules, or to go from atoms or molecules to moles, we can use the Avogadro's number. Converting between mass and amount of an element. Silver is used in jewelry and tableware, but no longer in US coins. How many grams of silver are in 0.0342 moles of silver? Okay, we want to find out grams of silver in this many number of moles of silver. Okay, now we know one thing, that is, what is the mass of 1 mole of silver? How do we find that? We find it from the periodic table. So periodic table will give us the molar mass of silver grams per mole. So that is for 1 mole. Then we can find out what is the mass of this many number of moles. So to convert the moles of silver to mass of silver in grams, we need the molar mass. Molar mass of silver is 107.9. Okay, always when you are solving problem like that, you're going to write down what is given to us. What we want is grams of silver, and we are given this number. So you write what is given to you, 0.0342 moles. And then you use the conversion. This conversion that comes from your molar mass, which you find from the periodic table. It tells you 1 mole, the mass is 107.9 grams. So in that conversion, mole need to be in your denominator, because our goal is to get rid of moles and have the answer in grams. And you put 107.9 grams. So use that as your conversion. So moles to moles get cancelled. So now you can find out the answer, which is, what's the answer? Let's do the calculation. I don't have it here. So 0.0342 times 107.9. That is 3.69. 3.690. But here we have 3 significant figures. The other one 4. This is a multiplication. So we keep it in 3 sig fix. So 3.69 is the correct answer. Okay. Got it? Okay. So let's move on with the next one then. Okay. Another one here. It's asking, gallium is a key element in solar panels, and the panels, calculators and other light sensitive electronic devices. How many gallium atoms are in 2.85 into 10 to the negative 3 moles of gallium? So it's asking the number of gallium atoms in these moles. So how do we approach this one? Okay, to convert moles of gallium to number of gallium atoms, we need to use the Avogadro's number. So first thing, we're going to always write down what is given to us. How many gallium atoms? So we want to find out the gallium atoms. Okay, that's what you want. And we are given 2.85 into 10 to the negative 3 moles. So that's what given to us. So you write that one first. 2.85 into 10 to the negative 3 moles. How do we relate moles to atoms? If you take 1 mole, how many atoms are there? That's the Avogadro numbers, right? So since you have moles here, you're going to write your mole in your denominator. So we know 1 mole has Avogadro number 6.022 into 10 to the 23. Okay, atoms. I ran out of space. And then you do this multiplication and make sure that you have a scientific calculator, and then you can do your calculations for the exponents. And this will give you 1.72 into 10 to the 21 gallium atoms. Okay, that's how you do that calculation. You first write down what's given to you, and then you use the proper conversion, going from moles to atoms. Okay, and this space is for that problem. Okay, iron is the main component of steel and is therefore the most important metal in society, also contained in our body. Okay, asking how many iron atoms are in 95.8 gram of iron. Now we want to find out iron atoms. Okay, how many iron atoms are in 95.8 grams of iron? We need to go from grams to atoms, right? So we want to find out the atoms. How do we get the atoms? First, we are given our answer in grams. Can we go directly from gram to atoms? No, we can go through the moles, right? Then you use the molar mass of iron. That will give us in grams per moles. That's the molar mass. And then we know 1 mole has the Avogadro number of atoms. So there we get the answer atoms. Now this involves 2 conversions. Okay, so 95.8, that's what we're going to start with. So 95.8 grams. Maybe I can start here. 95.8 gram iron. How do we convert grams to moles? Using the molar mass of iron. So the molar mass of iron is 55.85. So since we have grams here, you're going to use it. 1 mole of iron is 55.85 grams. Now where do you get this 55.85? From your periodic table. Okay, and then we want the number of atoms. We know the conversion. 1 mole of iron has Avogadro number of atoms, 23 atoms. So grams to grams got cancelled, moles to moles got cancelled, and you have your answer in atoms, and that is going to be 1.04 into 10 to the 24 atoms. You also do this calculation with your calculator and see if you also get these answers. 1.04 into 10 to the 24 atoms. Okay. And then the next problem that we're going to learn, convert between number of entities and mass of a compound. 1. Nitrogen dioxide is a component of urban smog. How many molecules are in 8.92 gram of nitrogen dioxide? Now in the previous problems, we only had a single atom like silver. And then we have iron, and then we have gallium, right? But now here we have a compound. That's the difference. Otherwise, it's the same thing. Okay? No, not you. Come on, where is my... there you go. Okay. So here we are going to look at mass of a compound. Nitrogen dioxide, we are given nitrogen dioxide. We need to know how to write the formula, which you guys are now expert in writing the formulas, right? Nitrogen dioxide, it is a covalent compound between non-metals, right? So nitrogen dioxide would be, there is 1 nitrogen and there are 2 oxygens, dioxide NO2. And how many molecules? We want to find out the number of molecules in 8.92 grams of nitrogen dioxide. Okay, first we need to find out the molar mass of nitrogen dioxide. So it is showing here how to calculate the molar mass. You guys already know there are 1 nitrogen, mass of nitrogen times 1. There are 2 oxygen, mass of oxygen times 2. So 1 nitrogen is 14 grams per moles plus 2 times 16 grams per mole for oxygen. So the molar mass of NO2 is 46.01. Okay, once you find out that, then what you need to do is you need to go from grams to entities or molecules. Okay, 8.92. So we start with 8.92 grams. What's given to us is 8.92 grams NO2, and then we're gonna use the molar mass to turn it to number of moles. 1 mole of NO2 is the molar mass of nitrogen dioxide, which is 46.01 grams, and then 1 mole of NO2 has Avogadro number of molecules, because we want molecules. 6.022 into 10 to the 23 molecules. Okay, molecules. And then you can see that the grams to grams get cancelled, moles to moles get cancelled. So you're going to have your answer in molecules, and that would be 1.17 into 10 to the 23 molecules NO2. You can also see the calculation here. Okay, converting between number of entities and mass of compound 2. Now we have ammonium carbonate. Okay, it's a white solid. It's a component of baking powder if you're making cakes at home. How many formula units are in 41.6 gram of ammonium carbonate? Now the first thing, we are given 41.6 grams. What is the first thing that we need to do? We need to convert it to moles. In order to convert it to moles, we need to know how to calculate, how to first write the formula ammonium carbonate, and then how can we find out the molar mass, which also you know how to find. Now what is the formula for ammonium carbonate? Now you can refer to your table that has all the polyatomic ions. Ammonium ion is +1 and carbonate CO3 is -2. Again, you can refer to find out what is the carbonate ion, what's the charge of it from your polyatomic ion table. So you have +1 charge and you have carbonate -2. Then what are you going to do? You can put them in parentheses. We're going to crisscross. Remember, we did this in our previous chapter. You put the 2 there. That will give you ammonium going to have 2 after the parenthesis, and carbonate will end up having 1. Normally you don't put 1, and when you have only 1 polyatomic ion, you also don't put parenthesis. So you can find that ammonium carbonate formula is this. Okay, and then we need to find out the molar mass, which you know how to calculate the molar mass. This is the formula. And then in ammonium carbonate there are 2 nitrogens, there are 8 hydrogens, 1 carbon and 3 oxygen. So 2 times the molar mass of nitrogen, 8 times the molar mass of hydrogen, and 1 carbon and 3 oxygen altogether will give you the molar mass of ammonium carbonate, 96.09. Okay, so we found that. we're going to find out how many formula units are in this many grams of ammonium carbonate. 41.6. So you start with 41.6 first grams. If you are given something in grams, what do you need to do? You need to convert it to moles using the molar mass. Molar mass is given as grams per moles, and then the gram should go to your denominator, 96.09 grams in 1 mole. We want to find out the formula units. So 1 mole contain how many formula units? Avogadro number of formula units, 6.022 into 10 to the 23 formula units. So you can see grams to grams get cancelled, moles to moles get cancelled. So you're going to find out the formula units in 41.6 grams, and that would be 2.61 into 10 to the 23 formula units of ammonium carbonate. So you can also see how it's been calculated, what I just did in the previous slide right here. Okay, and then the next question is asking how many oxygen atoms are in this sample. Now if you take ammonium carbonate, how many oxygen atoms are there? It's asking how many atoms, oxygen atoms are in this sample. So how many oxygen atoms do you see here? Okay, there are 3 oxygen atoms, right? Now we need to take into consideration this one. Let's say how to find out the number of oxygen atoms. Now, in the previous calculation A, we found that there are this many number of formula units in 41.6 grams ammonium carbonate. And in this compound, how many oxygen atoms? So this many formula units we have, and out of that, 1 formula units of ammonium carbonate has 3 oxygen atoms. Okay, so basically you multiply this number by 3 because there are 3 oxygen atoms. Okay, so take this number, multiply by 3, because if you take 1 formula unit, there are 3 oxygen atoms. That will give you the number of oxygen atoms. Okay. Okay, so that's how you calculate going from moles to mass, mass to moles, and also going from moles to entities, formula units or atoms, and also going from grams to molecules. Okay, if you're going from grams to molecules, then you have to go through molar mass. Okay. Now, mass percent from the chemical formula. So if you want to find out the mass percent, this is the equation type that we're going to follow. Mass percent of element X. Well, I'll start this in a new session.